Yeah, welcome to our first session. As mentioned, my name is Ingo Stalkov. I'm the head of sales at Optris. Next to me is my colleague, Andrei Nikolic.
Field application engineer at Optris.
And yeah, we're going to show you some insights of our company, of course, and also later we jump into some real applications of line scan applications, which you can do with our products. Just short introduction of the Optris GmbH itself. We are a manufacturer of any kind of non-contact temperature measurement devices, which means we are talking about pyrometers, cameras, of course, also accessories and the software. You will see in the examples today how this goes together. We are located in Berlin, where we also manufacture our devices. To get an idea, we are approximately 115 employees, and we have a wide range of different products. And as usual for a medium-sized company producing such units, we are worldwide present. This is a short introduction, and now we jump to some basics presented by André.
Exactly. Before we go to the real applications, just quick reminder about the basics of the line scanner. So this is a classic line scanner. You can see this is a single spot pyrometer. This pyrometer is looking on a rotating mirror. And in this way, we have a line which is created by the rotating mirror. And we can have this line scan function from the left to right. You can see it here as animation. And of course, there are some, well, let's say, yeah, that I wanted to show you. Aspects of the classic line scanner, as you can see, depending on the position of the spot, you have different spot sizes and of course also different shapes of the spot. What is Optris doing? Well, we're not using a pyrometer. We don't have a rotating mirror. We are using our Optris infrared cameras. And this is the line scan function of the camera. So you have the whole field of view from the infrared camera. You can choose any line inside this matrix. And then you can define just your line scanning area. So this can be done up to 125 lines per second. And you can also use not only one camera, you can also take two cameras. And then you have a wider range. You can have a wider field of view to do the line scan. So this is just the basics about the line scan. And now we will jump right into the applications.
Yes, to give some ideas, where do we find such line scanners? Yeah, most popular applications are to find in the glass industry. So we talk about float glass and also a glass tempering, but also in the cement and any kind of mining, rotating kiln. There you find such line scanners. And in the metal industry, such in the continuous casting process or even during welding processes, you can find such line scanners. But honestly, there are so many different applications, and we definitely will find further applications. But let's focus on those three most popular applications. Let's start with the glass industry, with the float glass industry. To one, they don't know too much about that application. A brief overview of what it's about. We're talking about float glass when we start really generating the pure material of glass for further treatments for windows, for shower doors, for any kind of. So it is a facility at least 400 meters long with an endless stripe of glass, and the whole process to ensure the quality and to have an opportunity to control the whole process, the temperature plays a big and important role. The problem is very often we are very limited in the visual access. So only a small gap is typically given to get access to the glass itself, and across the whole line, again, 400 meters long, customers are very interested in getting the information of the temperature profile across the glass to be sure if each process, we're talking about the long and slow cooling down curve, to get the right temperature. And by having this small slit, typically a line scanner is a good alternative to get the thermal information to control the whole process. Here we see how it is looking like. It is, as mentioned, a very long line, and you see, I hope I can activate. Oh, I just take this mouse, the laser pointer, so you see it a little more. So this is the whole glass line, and across this line, we have several points where customers are interested in getting the information. Here you see a sample of installation across from to the glass to see what's going on. then in the end can look like this. This on the left side, we see, or right above me, the live view, what the camera is seeing, and we see a small line across the glass. And what we're actually doing, we're collecting the information of each single pixel across this line, and we put this information next to each other to create such line scan. And in the end, we have an endless stream of temperature values. And out of this, we can read out the different zones, we can find hotspots, we can create the temperature profiles, we can even put alarms on each single sectors and areas to make the whole process able to control. Yeah, this is a short excursus into the float glass we keep in the glass industry, but now we go into a different world, into glass tempering.
Exactly, because now we're at the end, we're not in the front in the glass production. And you can see we want to measure the heat on the glass surface. We really want to see, is there a homogeneous distribution on the glass itself? And with this information, of course, we can see, is there still an ongoing quality? Is this changing over time? Is the furnace itself changing over time? And we can use this data, we can collect this, we can use it for quality control. And even if there are customers who want to try new recipes for their glass, they can prove that this is still working and this is the right approach. What is the, let's say, state of the art temperature measurement in this case? It's a top-down measurement. The line scanners are very known. So in this case, you can see it's measuring from the top down onto the glass, but there's a little problem. If we have special glass, especially low emissivity glass, then there's a special coating on the top side. And if you now try to measure from the top, there is no chance that you will get a true temperature measurement because the emissivity is very low. And even worse, this is acting like a mirror. In this case, you can see there are some reflections from the top. Yeah, thank you. From the heaters that are in the facility. So the temperature at this point is just not valid. So you need to reference actually from the downside. And Optris also tried an approach. We also created a top-down measurement system. But in the end, we said, okay, why reference from the top? If we can measure, why reference from the bottom? We can measure from the bottom. So that's why we created this bottom-up measurements. In this case, we have two cameras. The image of these two cameras is merged and get a line scan over the whole width of these two cameras. And that's why you can actually any kind up to 4 meters width or 4.5, I think, of the oven is possible. And here, this is also a live image from one of our installations. You can see we are measuring through the rollers. There's only a little slit. There's not space, so that's why we have the line scan function. The glass is coming, and in the end, in the software, this is represented as one image, the whole sheet of glass which is in the oven.
And this is actually what the customer is interested to see, the whole glass in one piece by having only one slit access to the furnace.
Okay, then I think we'll continue from glass to the next field of application, to the rotary kiln.
The rotary kiln are quite interesting, and in those applications we have a different situation. It is not a sheet of glass or a single object. It's another kind of endless product. It's a rotating kiln, and the customers in here, the users are interested in getting an idea of what's going on inside this. And of course, we cannot look through walls, but we can read out temperature information and take this as an indicator of the condition of this rotating furnace in the end. So we see from outside if there's sticking material, which can harm the refractory material inside, which creates a risk of breakthroughs. So here, the users are very interested in getting the temperature information across the whole shelf of this unit. And interestingly, in the past, the only way to get in complete thermal information of this is using a line scanner. But this kind of line scanner, we talked in the beginning, what Andre was explaining, because those kind of line scanners were able to create an image because we put one line to each other. Nowadays, we have thermal imagers available, industrial thermal imagers for reasonable prices. So even smaller companies can afford this investment to see such image information. So this is actually what users of line scanners, kilns like to see. They want to see the image. They want to identify where's a potential risk of hotspot. And if he is interested in having the complete plot of the kiln itself, we can use our line scan function as we see right here. So across this live view on the left side, we can put this live infrared image. If it's too long, again, we can even merge several units, quite easy. And we can create one line scan. So that means we can roll off the lines, the kiln completely and get this thermal information. We could even create different zones of interest to identify on which position we have some situation, like in here, a certain risk of overheating the process or something. So the user gets a feedback of what's going on inside. Yeah, this is one short explained example of this rotary kilns. And now we go further to the metal world.
Exactly. So for the metal world, in this case, for the slabs or the billets, in the past, there was always line scan used. But nowadays, I mean, we saw it in the application before, there's also the possibility to use the infrared camera. In this case, you can see the camera itself is not installed directly to the slabs or to the production facility, but in the control room. So we are measuring through there's even a window from this control room through the projector window onto the billets. Of course, if somebody use line scan function, this is still possible with our cameras. So from this continuous casting process to the second one, again, this is also, like you see, an endless casting process of real hot metal. In this case, you see the line in our software. You could technically also use this as a line scan again, or you can just create, like here, several measurement points and then read the data out of those points, or you can take it as a line scan and have the whole process, the whole casting process in one image. So you see with our camera and the software, both solutions are possible if you want to have the, like, let's say old school, the state-of-the-art line scan function, or you use the infrared image. And then you can also just take snapshots or little videos or take the data out of this infrared image. Okay, so
I think we are through.
We are through. Just a short overview, really short overview of possible applications in scanning.